Hi, welcome to my channel. In this video we are going to go through a word exercise on capital investment analysis using net present value and payback period. Let's start. So imagine Alessia and Aisha want to open their business of food truck and they have different options. Option 1, they could renovate a school bus to make their food truck. Option 2, buy a second-handed equipment for their kitchen. Option 3, to buy a new food truck full equipped, or start small and buy an electric bike to deliver. Alessia and Aisha need to evaluate the different options and see which one has a better value for them. The first project of the school bus requires an initial investment of $75,000 and it yields $44,000 for the following 3 years. The second option requires an investment of $50,000 and yields $23,000 each year. The third option requires an initial investment of $125,000 and yields earnings of $70,000 for the 3 years. The fourth option only needs an initial investment of $2,000 and will yield $12,000, $13,000, and $14,000 in the 3 next years. So before Alessia and Aisha can decide which investment to take, they need to evaluate which project is more valuable for them. So let's see what is the net present value of those projects. So let's draw the timeline. The project has a life of 3 years. So the initial investment is $75,000 and it yields $44,000 in year 1, year 2, and year 3. Since the payments are constant for the 3 years, we can qualify this as a constant annuity of 3 years. So the net present value of project 1 is equal to the initial investment minus $75,000 plus the annuity formula. So $44,000 divided by the rate, which is 15%, 0.15, multiplied by 1 minus 1 divided 1 plus 0.15 power 3 because it's 3 years. So the net present value of project 1 is equal to $25,461.9. So let's take a look at project 2. We have an initial investment of $50,000 and it yields $23,000 for 3 years. This is also an annuity constant of 3 years. So the net present value of project 2 is equal to the initial investment minus $50,000, the annuity formula with $23,000 as a constant payment, divided by the rate, 15%, multiplied by 1 minus 1, divided by 1 plus 0.15, power 3, which is 3 years. The net present value of project 2 is then equal to $2,514.18. Now let's take a look at project 3. Project 3 has an initial investment of $125 and it yields $70,000 for the following 3 years. We have again an annuity constant of 3 years. So the net present value of project 3 is equal to the initial investment minus $125 plus the annuity formula with $70,000 as a constant, 15% as the rate, and 3 years as the time of the annuity. The net present value of project 3 is equal to $34,825.76. Now let's take a look at project 4. Project 4 requires an initial investment of $2,000 and it yields $12,000, $13,000, and $14,000 in the following 3 years. The net present value of project 4 is equal to the initial investment minus $2,000 plus each of the cash flows for year 1, year 2, and year 3 discounted by the rate 15%. The net present value of project 4 is equal to $27,469.88. Now, Alessia and Aisha can compare the net present value of the 4 projects. And following this approach, they can see that project 3 is the most profitable. Now, what does it mean to have non-mutually exclusive projects? This means that 2 or more projects can be taken simultaneously. So, Alessia and Aisha have a 5th option. They can take project 1 and project 2. The net present value of project 5 will be then the net present value of project 1 plus the net present value of project 2. So, project 5 has a net present value equal to $27,976.1. Now let's take a look at the payback period for each of the projects. How much time do Alessia and Aisha need to wait to recover their initial investment? Let's start with project 1. The initial investment for project 1 is $75,000. This is what Alessia and Aisha need to recover. In the first year, they will recover $44,000. So after 1 year, they only have left $31,000 to recover. In the second year, they will receive other $44,000, which is more than what we need to recover. So to find out the fraction of year needed to recover the rest of the money, we divide 31,000 on 44,000 and we have 0.7. So the payback period for project 1 is 1.7 years, which is equivalent to 1 year and 8 months. Now let's take a look at project 2. It requires an initial investment of $50,000, which is what needs to be recovered. In the first year, Alessia and Aisha will recover $23,000. It means that after 1 year, they have only $27,000 to recover. At year 2, they will recover other $23,000. So it means that after 2 years, they have only $4,000 to recover. In year 3, they will recover other $23,000. So I divide 4,000 on 23,000 and I have 0.17 years. So the payback period of project 2 is 2.17 years, which is equivalent to 2 years and 2 months. Now, following the same approach for all of the projects, I can see that project 3 has a lifetime of 1 year and 9 months and project 4 a lifetime of 2 months. So evaluating the projects on their payback period, we can say that project 4 is the most profitable as it takes less time to recover the initial investment. That's all for now. Remember to like the video and subscribe to my channel for future content. Bye bye!